Hello and welcome to today's class. So today we are going to be considering the types of sets. Number one, we have the empty set or null set. And then number two, we have the finite set. Number three, we have the infinite set. Number four, we have the singleton. Number five, we have the subset and superset. And number six, we have the power set. So let's take them one after the other. First of all, empty set. What is an empty or null set? An empty set is a set that has no element or member. An empty set is a set that has no element or member. It is usually denoted by a curly bracket without no element in it, or phi. It's either you use a curly bracket without no element in it or phi. Secondly, the finite set. So what is a finite set? A finite set, as the name implies, is a set that contains a restricted number of elements. A finite set is simply a set that contains a restricted number of elements. Example, D equals, you open your curly bracket, X, such that X is days in the week. So this is finite because you know the number of days in the week. So we have 7 days in a week. So it is finite and direct. Thirdly, the non-finite set. What is non-finite set? A non-finite set is a set whose number of elements cannot be counted. A non-finite set is a set whose number of elements cannot be counted, unlike the finite set. Finite sets can be counted, but non-finite sets cannot be counted. Note this, for a set of non-finite terms, 3 dots are usually used to show that they continue. In order for you to identify a non-finite set, you would see 3 dots at the end of the elements inside the curly bracket. Example, a set of even numbers. A set of even numbers. Now, what are the even numbers here? M equals, you open your bracket, 2 is an even number, comma, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number. So if you continue to list out or write down the even numbers we have, I don't think you will be able to finish up today. So in order to tell that it is a non-finite set, you put your 3 dots to show that it continues and it keeps going. Then you close your curly bracket. So therefore, M is infinite. Number 4, we have the singleton. What is a singleton? A singleton is simply a set that contains just one element. A singleton is a set that contains just one element. So we have here M equals, you open your curly bracket, 15, and then you close your curly bracket. So we just have one element inside this bracket. So this makes it a singleton. If C equals 3, 5, this is not a singleton because we have two elements inside the bracket. So this is not a singleton, but this is a singleton. And also, if you see something like this, a curly bracket and then phi inside the curly bracket, this is a singleton. Remember, an empty set has no element in it, and an empty set is just a curly bracket without no element in it, or phi. But when we have phi encased in a curly bracket, it becomes a singleton. So this is a singleton. And then the fifth one, we have subset and superset. Given two terms M and N such that all the elements in N are contained in M is called the subset of M. Given two terms M and N, we have M and N such that all the elements in N are contained in M is called the subset of M, written as N. So let's take an example for proper understanding. A equals 1, 2, 3, 4, and 5. Then you close the bracket. While B equals 2 and 3. Now, if you look at this very well, you will notice that all the elements in B are found in A. We have 2 and 3 here in B, and we also have 2 and 3 in A. So B is a subset of A because the elements of B are found in A, and then A is a superset of B.